As you can see, this is after like thousands of generations, probably running it for maybe an hour, and they are much better at walking after a long time, but they seem to plateau at around here. This seems about as good as I can get them at walking. So yeah, the neural network is run on the graphics card using CUDA, so you need an NVIDIA graphics card to run this program. Pretty dang cool. I like the way they move. Not bad. The only thing that I did that was slightly more interesting was when I do the mutation, I say that if the mutation led to a lower score, then I just undo the mutation. The way that the system evolves is, let's say we get the top 20 guys, with the 20 guys with the highest score, and we get the 20 guys with the lowest score, and we replace the brains of the guys with the lowest score with the brains of the guys with the highest score. And then after that, we just apply a mutation on all of them. And yeah, that mutation could be better or worse for its score. If it's worse for its score, then, like I said, we'll undo the mutation and I'll try out a different mutation. So, and yeah, their score is plateaued at around 39 right now, and I can't seem to get it any higher than that. I've been running it for a while. So, it seems like they've reached a maximum, a local maximum anyway. Pretty dang cool. I think it'd be cool if people could like try and run this and see how far they could get these guys. With different seeds, you know, you might end up with a different way of walking. I'm not sure. I've only been training this one really, so I feel like if you tried out a different starting condition, they would find a different way. The other interesting part about them is that their brains also have 2 inputs and 2 outputs, which link up to each other. So it has 2 of its outputs right to the robot's what I'll call memory. So 2 floating point numbers, and then that memory is fed back into the neural network every physics step or whatever. So they actually get some kind of cyclic movement using that recurrent thing. Because I did remove it, I set it to 0 and saw how they moved, and yeah, they were definitely using that recurrent part of their neural network to produce some of their cyclic movement. But yeah, pretty interesting. When you have a really basic sort of physics system based on just like balls and friction with the ground, and just some spring edges that contract and pull towards each other. I actually like hand-coded the geometry of the robots using their body is basically a tetrahedron, and they have 3 like symmetrical legs that come out of 3 faces of the tetrahedron, perpendicular angle, whatever, to the faces of the tetrahedron. So they have those 3 legs, and those 3 legs each have 6 muscles. So in total they have 18 muscles, and so 18 outputs. And then the 2 outputs also for the memory. And then they also have 20, I had to come up with 20 inputs. So the reason why they have the same amount of inputs and outputs seems like a pretty big brain. They have 20 inputs and 20 outputs, and the layer size for each one is 20. So that means that the matrix is a 20 by 20 matrix for each layer of the matrix, for each layer of the neural network. And there's 4 layers. So that would be 20 times 20 times 4, so 1600 weights, and then 80 biases, because 4 times 20. So they have 1600 parameters, and the reason why I just use square matrices everywhere is because I thought it was easier to program for the GPU. It was just slightly more convenient, and would make better use of the GPU to have all the layer sizes the same. I wonder how fast it would run if I tried to run it on the CPU, right? The neural network code on the CPU. I have no idea. I haven't tried with this program yet. But yeah, it uses CUDA. So yeah, thanks for watching anyway. That was my best explanation in one take. And have a good one.